right, here we go with objective 63, which is our first objective that talks about solving quadratics. So a lot of you have been asking, why is factoring important to us? We've been doing this for the last few days, and why is it important? Factoring is important because it helps us solve these equations. We want to find solutions for x. What can x equal in these equations? Okay, so let's start by talking about solving quadratic equations. In order to solve quadratic equations, the first thing that we need to do is set the equation equal to 0. And I'll put in parentheses, we want to move everything to one side. So move everything to one side. So looking at this example down here, we've got a quadratic. It's got the degree is 2, and everything is moved over to one side. It's all equal to 0. So all of our terms are moved onto the left-hand side. So that one's good to go. We've already got step 1 done for that one. Step 2 would be to factor the expression like the previous objectives. So jumping back down to this first example, we have x squared minus 5x minus 36 equals 0. We want to factor this just like we normally have in the past. So we look at the last term. What factors of 36? So what are the factors? What numbers multiply to get to 36? We have 1 times 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. And then in order to factor this, we need to know what pair of factors add up to get that middle term. So add up to get to negative 5. Well, 1 and 36 don't, 2 and 18 don't, 3 and 12 don't, 4 and 9, if we had positive 4 and a negative 9, that would add up to negative 5. So factoring this, we have x plus 4 and x minus 9. So this is no different than what we've done in the past. But now we have an equation, so it's equal to 0. Step 3, in order to solve this, we need to apply the zero product property. And we'll talk about that in just a moment. Apply the zero product property to solve each factored term for the variable. So apply the zero product property to solve each factored term for the variable. So let's talk for a moment. The zero product property tells you that if you have a product, a number times another number, that is equal to 0. So say I have a times b equals 0. The zero product property tells us, well, if we have this, two numbers that multiply to get to 0, then either a equals 0 or b equals 0. So one of those factors has to be 0. Well, let's test it out. Let's see if it works. So if we have this, a times b equals 0, if we had a equals 0, we would have 0 times b. Does that equal 0? Yes, it does. 0 times anything. B can be any number, any real number, and we would get that's equal to 0. The same thing is true if b is 0. So we have a times 0. Does that equal 0? Well, yes, a can be anything. If b is 0, then a times b is also 0. So the zero product property tells us if we have any two numbers multiplied together that equals 0, then one of those numbers has to be 0. At least one of those numbers. So looking back at this, we've got this times this. We've got x plus 4, that's one term, times x minus 9, which is another term, and that's all equal to 0. So because we have this times this equals 0, we can use the zero product property. So remember, when we found this, we set each thing equal to 0. So each factor equal to 0. So we can set x plus 4 equal to 0, and we can set x minus 9 equal to 0. And we can solve both of these equations. So here we have x plus 4. To get x by itself, we have to subtract 4, and we have x equals negative 4. For the other equation, we have x minus 9. In order to get x by itself, we add 9 to both sides, so we have x equals positive 9. So we have x equals negative 4 and x equals 9. We have two solutions. So if we were to plug in either negative 4 or 9 back into this original equation, you would find that it would still be true. If you were to plug in either negative 4 and 9, this would still work. It would be true. This is because when we're working with quadratics, so remember quadratics is degree 2. That's going to be in the form x squared. And you're going to see more of this in some of the higher level math, so like pre-calc, definitely calculus. You know, we get that from the degree. This tells us that we have two real solutions. At most, two real solutions. Okay, so that comes from the degree of our polynomial. So when we're solving these quadratics, you're most likely going to have two solutions. So let's try letter B. So the first step is set the equation equal to 0. We want to move everything to one side. So here we have two terms on this side. We have one term on this side. Let's move this one over to the other side. So in order to move this over, we have a minus 3a. So we add 3a. And then, do we have any like terms here? We have a squared, we have an a to the 1, and we have a 40. There are no like terms, so there's nothing to combine it with over here. So you have a squared plus 3a minus 40, and that's all equal to 0. This minus 3a and this plus 3a cancel, and just gives us 0. And then we factor as normal. So we have our third term is 40. So factors of that is 1 and 40, 2 and 20, not 3, but 4 and 10, 5 and 8, and that's it. We want to know what pair of factors add up to negative 3. Add or subtract. So let's try it. Let's see. 1 and 40 doesn't work. 2 and 20, 4 and 10. 5 and 8, if we were to have a positive 8 and a negative 5, that would give us the positive 3 that we need. So we use this here. So we have a plus 8 and a minus 5. And that's all equal to 0. Remember, maintain the equation. We got to bring down the equals 0 every time. So then we apply the zero product property. We have this times this is equal to 0. So we can set each of those factored terms equal to 0. So you have a plus 8 equals 0. We have a minus 5 equals 0. Solving each of these equations, we can subtract 8, and we have a equals negative 8. And then for this one, we add 5 to both sides, so we have a equals positive 5. So we have two solutions, a equals negative 8 and 5. So this is objective 63, solving quadratics.